Hello friends, welcome back to my channel BOE Tutorials. In this video we will discuss about minimum quantity of air required for complete combustion of 1 kg of solid or liquid fuel, products of combustion, axis air factor, minimum quantity of air required for complete combustion of 1 kg of solid or liquid fuels. It will be seen from the previous discussion that an adequate supply of oxygen is essential for complete combustion. If the combustion is complete, then and then only maximum heat is available from a given fuel. The theoretically exact amount of oxygen required can be calculated with the help of combustion equations. We have already seen that the oxygen for the combustion of a fuel is to be obtained from the atmospheric air. Although in some case a small amount of oxygen is a constituent of the fuel itself, air is a mixture of oxygen, nitrogen, a small amount of carbon dioxide and small traces of rare gases such as neon, argon, krypton, etc. Let's consider 1 kg of a fuel, the ultimate analysis of which shows that carbon is CkG, hydrogen is HkG, oxygen is OkG, and sulfur is SkG. We have seen in the previous video that 1 kg of carbon required 2.67 kg of oxygen for its complete combustion. Therefore, CkG of carbon will require C into 2.67 kg of oxygen, which is equivalent to 2.67 CkG of oxygen. 1 kg of hydrogen required 8 kg of oxygen. Therefore, HkG of oxygen required 8 at kg of oxygen. 1 kg of sulfur required 1 kg of oxygen. Therefore, Skg of sulfur required Skg of oxygen. Therefore, the quantity of oxygen required for combustion of 1 kg of fuel is 2.67 C plus 8H plus S. If the fuel contains O kg of oxygen, then the oxygen required for air for the complete combustion of the fuel will be 2.66 C plus 8H plus S minus O, which can be otherwise written as 2.66 C plus 8 into H minus O by 8 plus S. The term in the bracket being known as the available hydrogen. Thus, we get the formula for determination of minimum quantity of oxygen for complete combustion of a solid liquid fuel, whose ultimate analysis is known. The formula can be written as under: minimum oxygen required for complete combustion of a fuel is 2.66 C plus 8 into H minus O by 8 plus Skg. This is equation 1. Since air contains 23% by mass of oxygen, 1 kg of oxygen is contained in 100 by 23 kg, that is 4.35 kg of air, and thus the minimum quantity of air required for complete combustion of 1 kg of fuel will be 4.35 into 2.66 C plus 8 into H minus O by 8 plus S kg. Simplifying the equation, we get the quantity of air required for complete combustion of 1 kg of fuel will be 11.6 C plus 34.8 into H minus O by 8 plus 4.35 as kg. This is equation 2. Product of combustion: 1 gram carbon produce 44 by 12 gram CO2. C gram carbon produce 44 by 12 gram CO2 per gram fuel. 1 gram H2 produce 9 gram water. H minus O by 8 gram H2 produce 9 into H minus O by 8 gram water per gram fuel. Product of combustion per gram of fuel is equal to 44 divided by 12C plus 9 into H minus O by 8 plus 256 plus nitrogen 0.768 times weight of air, or nitrogen is equal to 4.31 minus 1 into 32 divided by 18C plus 8 into H2 minus O by 8 plus S. Theoretical required oxygen from 1 gram of substance is given here. Carbon to CO2 theoretically are required 2.67 kg. Carbon to CO theoretically are required 1.33 kg. CO to CO2 theoretically are required 0.57 kg. S to SO2 theoretically are required 1 kg. H to H2O theoretically are required 8 kg. In all these equations, it is assumed that available hydrogen is H minus O by 8 and not H per gram of fuel. The reason being that hydrogen required 8 times O2 for combustion, hence whatever O2 is present in coal, the same will be exhausted within O by 8. As far as products of combustion are concerned, we have not added in the above equation any moisture produced. If O2 is C gram per gram of fuel, added 9 by 8 O as water vapor produced, also add moisture in coal and air directly. X is air factor. The assumptions that the air or oxygen just equal to the theoretical amount will lead to psychrometric combustion. Proposed ideal conditions. In practice, air or oxygen in excess of the theoretical amount has to be supplied to approach conditions of psychrometry. This leads to the definition of X is air factor, defined as the fraction of air required in excess of the theoretical air. The concept of excess air factor is a theoretical concept to characterize the state of the combustion system. It is evoked when it is realized that the considerations for ideal combustion are not likely to be met. The implicitly assumes that the lack of psychrometric combustion is just due to insufficiency of the external air available, which is the hardly to complete story. There exists a number of simple empirical equations for excess air ratio. There are based on nitrogen, oxygen and carbon monoxide content in fuel gas and are excess air factor is N2 divided by N2 minus 79 divided by 21 into O2 minus half CO, or excess air factor is O2 into K divided by 21 minus O2 plus 1, or 21 divided by 21 minus O2, where N2, O2 and CO are exhaust gases component in volume percent and K is a constant factor for fuels. Value of K is given in the following table for some of the fuels. Heavy furnace oil 0.944, furnace 3 oil 0.934, kerosene 0.929, propane 0.916, butane 0.919. Air and gas volume calculation, excess air determination or excess air and Heat loss will be described in detail in next video. So friends, if you like this video, then like and share. Also don't forget to subscribe this channel and press bell icon for getting notification of my upcoming videos.